Hey students, I just wanted to try something new here. I'm going to go through a video explaining today's PHET with you so you can have a reference to look back at it if you have any questions. So today we're going to look at, again, the universal law of gravitation. So here on your assignment, again, which can be found in Canvas, we're going to look at two research questions. Number one, how does the mass of an object change the gravitational pull on two objects within a system? Question two, how does the distance between objects in a system change the gravitational pull between them? Okay, so we're going to change mass and distance. Okay. So the first thing I want to do when you load up the assignment, which you can see, or sorry, the PHET, which you can see over here, is when you load it up, there are some things that you can change. So we're going to have two masses. Mass one is going to be in the blue, and mass two is going to be in the red. Okay, notice how you can change of the two objects, okay? And you can change how far apart these two objects are. So this whole thing is our system. And again, we're seeing how does mass and how does distance affect the strength of a gravitational pull, okay? So the first things I want you to do is just explore the simulation, okay? So it says, how does changing the distance between the objects in the system affect the force between them? Okay, so your force is measured in newtons. Okay, and you can see that up here, these are your newtons. Okay, so as we're doing this, you can ignore the zeros before it, and let's just deal with the actual whole numbers down here. Okay, so as we change the distance, you're going to notice that the newtons, or the amount of force, is changing. And as the objects get closer or further apart, what happens to the strength of that gravitational pull? Okay. The next question here is what happens to the force between the objects in the system when mass 1 increases? So an increase means it gets larger. So when I increase the mass, notice what's happening to that force number. Okay. And question 3 over here. What happens to the force between the objects in the system when mass 2 decreases? So if I decrease the mass or I make the object have less mass, notice what happens to the strength of that gravitational pull. Okay. And then the three things that you can change in this experiment are one, the force, two, the mass, and three, the distance between the objects. Okay, so I'm going to hit refresh to reset everything back to normal. And let's look at our first experiment. Okay, number one, how does mass change the gravitational pull on two objects? Okay, so in this case, the independent variable we are going to change is going to be the mass. More specifically, mass 1. So we are only going to mess with mass 1. Okay, and what we're going to measure in this case is the force. Okay, the strength of that gravitational pull between the two objects. Okay, the constant here that needs to be the same is going to be the distance between the two objects. Okay, so let's set up our experiment to collect the data. So right here in the data, it says change the mass of the blue object, mass 1, and record the gravitational pull. You're going to leave the red mass at 100 the whole time. So we're going to take mass 2, or the red mass, we're going to go down to 100 kilograms, and that is going to stay at 100 kilograms the whole time. Okay. The next step is you are going to set the two objects as far apart on the ruler as you can. Okay. Notice how they are as far apart, and when they are both 100 kilograms, notice how the force between the two objects is 6,674 newtons. Okay, I've already recorded that information for you right here, 6,674. Okay, and the next part that you're going to do is you are just going to increase mass 1 by 100 each time and record your data. So you're going to record how strong that gravitational pull is when mass 2 is 200 kilograms, 300, 400, 500, 600, all the way down to 1,000 kilograms. Okay, so let's do one example together. We can see that if I increase mass 1 by 100 kilograms, okay, notice how the force or the strength of my gravitational pull is now 13,348 newtons. Okay, 13,348. Okay, so now I can go down and I can graph this information. Notice how I've already done the 100 before you. So let's read this. Make a graph of your data. Fill in the squares up to the range the number falls in with a background color. Use a different color for each mass column. Okay, I will show you how to do that. So for example, in that first example, we got to 6,674. Notice how 6,000 falls between 0 and 10,000. Okay, so number 200, we got 13,348. So I'm going to go over here, and since 13,000 falls within my 10,000 numbers, I'm going to highlight up by clicking down. So I click and highlight up, click these three drops. I'm going to find the spill button, and we're going to choose just a color to spill it. In this case, I'm going to use yellow. Okay, so now I can see here that as my mass increased by 100 kilograms, notice how the gravitational pull increased as well. It got stronger. So once you get through all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points, you can then answer this question. Summarize this graph in one sentence. Answer this initial question. How does mass change the gravitational pull on two objects? Okay. All right. Your second test, we're going to deal with distance. So distance is what we're going to change in test number 2. So what we're going to measure still is going to be the force, right? The strength of that gravitational pull between two objects. The constant, what must be kept the same this time, is going to be the mass. Okay, so all we're going to change in part 2 is distance. How does distance affect the strength of a gravitational pull? Okay, so we're going to look at this a little bit differently, but we're going to use the same idea. So, data question. Change the distance between the objects for each trial and record the gravitational pull. So you're going to keep the mass the same for each object. So each object is going to be 100 kilograms. Okay. So again, remember, you can leave off those extra zeros, and we're just going to look at the numbers right here. Okay. So you can leave off the zeros, okay, and begin with the decimal point. So our thing is to look at what happens to mass when they are 10 meters apart, 9, 6, 4, all the way down to these two objects being 1 meter apart. Okay, so how we're going to do that? So we're going to set our two masses as far apart as they can. Okay, and we're going to look at the gravitational pull. Notice how it starts at 6,674 newtons. Perfect. So we're going to make the same graph. Gravitational pull when two objects are 10 meters apart, 6,674. So we're going to click down in here. Okay. We are going to click the two dots, hit the spill button. We're going to make it a color. Okay. And then we're going to bring these two objects 1 meter closer. And as this gets closer, these two objects get closer, notice what's happening to the strength of that gravitational pull. Now we're at 8,240 newtons. Okay. This one still right here is within the 0 to 50,000 range. Okay. And we should be able to see what's going to happen to that strength of gravitational pull as these two objects get closer and closer. Then you should be able to summarize this graph in one question. Again, if you have any questions, you can rewatch this video. You can ask someone next to you, or you can always raise your hand and I will be right over to help you. I hope this helps. Thanks. Bye.